Hello students, welcome to all. This is Dr. Vigneshwar Mekha, lecturer in geography. Here we shall discuss about isostasy. For your convenience, this session is divided into 6 major points which are as the following. 1. Introduction. 2. Meaning and definitions of isostasy. 3. Discovery of concept of isostasy. 4. Isostasy concept of Archideacon part. 5. The isostasy concept of Sir George Airy, and 6th one, isostatic adjustment on the surface of the earth. First, let us move with the introduction. There are a wide variety of relief features with changing magnitude, such as huge mountains, dissected plateaus, flat plains, lakes, low-lying seas and oceanic basins, falls and rift valleys, etc. lies on the surface of the earth. All these land features differ from each other in terms of their height, width, size, area, etc. and they are probably balanced by certain definite principles, otherwise these would have not been maintained a state of isostatic balance and would not be in either present form. There must exist certain invisible energies behind producing such balance, which called as isostasy. As soon as this balance is distressed, there must flinch ferocious earth crustal movements and plate tectonic procedures. Now, the learning outcomes of this module. After studying this module, you will be able to define the isostasy, to understand the development of the isostasy concept, to understand the concept of Airy and Pratt and Bovie. The meaning and definitions of isostasy. The word isostasy is derived from the Greek word isostasios, which means equiforce or equal standing. In other words, the gravitational adjustment of the earth crust is isostasy, a state of balance. The term isostasy was first used by the American geologist Clarence E. Dutton in 1889 to explain his view to indicate the state of mechanical equilibrium under the control of natural laws between the high upstanding areas of the earth's surface, mountain ranges, plateaus and contiguous lowlands, etc. exist over the rotating earth planet. According to Dutton, the upstanding parts of the earth, that is mountains, plateaus, plains and oceanic basins, must be compensated by lighter rock material from beneath so that the crustal reliefs should remain in mechanical stability. It means the less dense materials of the earth's surface must float over the denser magma of the earth's interior. Now, we will look into the definitions. Encyclopedia Britannica defines isostasy as a principle in earth science whereby one understands why continents stand nearly 3 miles above the floor of deep oceans and why a major chain so high above the general continental surface. S.W. Aldrich and R.S. Morgan stated that isostasy is a complex body of ideas dealing with the relation between outer crust of a rotating earth and underlying layers. According to J.S. Steers, this doctrine states that wherever equilibrium exists on the surface of the earth, equal mass must underlie equal surface area. According to Arthur Holmes, isostasy is for the ideal condition of a gravitational equilibrium that controls the height of continents and ocean floors in accordance with the density of their underlying rocks. Now, the discovery of the concept of isostasy. The concept of isostasy has been comprehended in a different way by various geologists all of a sudden, but its concept raised out of steady thinking in terms of gravitational attraction of gained mountainous masses. A brief history of the discovery of isostasy concept is as the following. Even though the term isostasy was first used by C.E. Dutton, the knowledge was first put forth by Pratt, who analyzed the theory in detail. Prior to the Pratt, Pierre Bouguer, the French scientist, during his geodetic survey in the Andes Mountains in 1735-45, identified that the deflection of the plumb line towards the towering volcanic peak of Chimborazo was very less than he had estimated, and recorded his suspicion that the gravitational attraction of the Andes is much smaller than that to be expected from the mass represented by these mountains. Likewise, Boscovich, a French scientist, preached that high temperature in the earth core triggered expansion in rocks beneath mountains, thus diminishing their density. The height of the mountains compensated for their density. Sir George B. Airy, the astronomer royal, stated that the continents which are made up with the less material seol are floating over the substratum which is made up of denser material seema. Similar discrepancies were noticed during the trigonometrical and geodetic survey of the Indo-Gangetic plain for the determination of latitudes under the supervision of Sir George Everest, the then Surveyor General of India in 1859. When the difference in latitude between Kalyanpur and Kalyana, that is 603 kilometers due north about longitude 78 degrees east, was determined by the direct triangulation method and astronomical methods, it was found that the two results differed by 5.236 seconds of hour. The latitudinal distance measured with the help of the astronomical method was less by 5.236 seconds of arc, which is equal to a distance of 108 meters on the ground. The discrepancy was considered to be due to the attraction exerted by the enormous mass of the Himalayas and the deflection of the plumb bar used for leveling the astronomical instrument of Kalyana, which was close to the Himalayas. Archdeacon Pratt astonished a lot to identify the above variations due to the distance between Kalyana and the Himalayas was barely 96 kilometers. Pratt therefore concluded that the aforementioned variation was because of the attraction of the Himalayas on the plumb line. The point to be observed here is that astronomical determination of latitudes is done by the direction of the independently suspended plumb at a place. The plumb line shows the attraction direction of a place. As the shape of the earth is geoid, the plumb line on the sea level gets deflected a bit instead of being vertical. The isostasy concept of Arcadian Pratt. While studying the above gravitational variances, Pratt opined that Himalayas had resulted the deflection in plumb line. So as to unravel the problem, Pratt has calculated gravitational attraction of the Himalayas, taking their average density equal to that of the earth crustal rocks as 2.7 grams per cubic centimeters. He was amazed to find out the actual difference between the two places, that is in geodetic survey of Kalyana and in Kalyanpur, should have been 15.885 inches instead of 5.236. This means that the Himalayas attraction should have been greater than that was observed. The figure on the screen reveals that the deflection of Plumbhog near mountain chains is less than expected. In order to unravel the problem of fewer attractions of the Himalayas, Pratt has presented a couple of alternatives. One, the Himalayan mountains formed with the rocks of low density. Two, local heavy attraction because of major landforms was compensated for by same deficiency of density below the surface. In the above circumstances, Himalayan mountains attraction might have been low so that the plumb line deflected less. The second alternative supported by the several scholars. In views of Pratt, there is inversely proportional relationship between density and height of the reliefs. Therefore, the land features above the level of compensation above which there is a difference in the density of different columns of land, but below it there exists equal density. There would be no change in density within one column, but it changes from one column to another above the level of compensation. Accordingly, the central theme of the Pratt's isostasy theory can be expressed as column of uniform depth with varying density. According to Pratt, equal surface area must underlie equal mass along the line of compensation. This statement may be explained with an example with the figure that appears on the screen. There are two columns A and B along the line of compensation. Both the columns A and B have equal surface area, but there is difference in their height. Both the columns must have equal mass along the line of compensation, so the density of the column A should be less than the density of column B, so that the weight of both the columns become equal along the line of compensation. Thus, Pratt's concept of inverse relationship between the height of different columns and their respective densities may be expressed in the following manner. Bigger the column, lesser the density, and smaller the column, greater the density. According to Pratt, density varies only in the lithosphere and not in the pyrosphere and barysphere. Thus, Pratt's concept of isostasy was related to the law of compensation and not to the law of flotation. According to Pratt, different relief features are standing only because of the fact that their respective mass is equal along the lines of compensation because of the varying density. This concept may be explained with the help of an example. The figure on the screen, level of compensation and blocks of different metals. Next, the concept of Sir George Airy. Sir George Airy, an astronomer royal, suggested that Earth's crust is supported by underlying denser material, that the weight of mountain is balanced by light materials extending as the roots in the denser medium. According to Archimedes, a floating body displaces liquid equal to the volume of submerged part of the floating body. Greater the part of the body above the liquid in which it is floating, the greater the part of the body inside the liquid. According to air, continents are supposed to be floating on the denser material, CIMA, constituting the substratum. In other words, CO is floating over the CIMA. As stated earlier, the whole controversy revolved around certain features regarding the smaller gravitative attraction of the Himalayan mountains. For example, an iceberg that is relative density 0.9 grams per cubic centimeter floats in the water in such a way that for every one part to be above water level, 9 parts of the iceberg remain below water level, as shown in the figure that appears on the screen. If we assume the average density of the crust and the substratum to be 2.7 grams per cubic centimeter and 3 grams cubic centimeter respectively, for every one part of the crust to remain above the substratum, 9 parts of the crust must be in the substratum. In other words, the law of flotation demands that the ratio of freeboard to draught is 1:9. It may be pointed out that Airy did not mention the example of the flotation of icebergs. He simply maintained that the crustal parts, that is land masses, were floating like a boat in the magma of the substrate. In order to prove this point, the concept of flotation, Airy took several blocks of iron of the same density but unequal lengths and put them in a basin filled with the mercury. The iron blocks sunk up to varying depths according to their length. The highest iron block was found to sink to the greatest depth. The figure on the screen explains you about the different iron blocks to different depths according to Airy's concept. This analogy of iron blocks of equal density and of varying depths, varying lengths to prove the concept of flotation, it would mean that if Mount Everest is 8,848 meters high and if the ratio assumed of draught and freeboard are correct, then there is a downward projection of lighter material beneath that mountain reaching a depth of 79,632 meters depth, that is around 80,000 feet. The uplifted land masses displace the material of denser substratum of the considerable depth through their long roots so that balance is maintained. On this basis, Airy propounded the concept of columns of uniform density with varying thicknesses. Bowie has opined that though Pratt does not believe in the law of flotation as stated by the Sir George Airy, but if we look minutely into the concept of Pratt, we certainly find the glimpse of law of flotation indirectly. Similarly, though Pratt does not believe directly in the concept of root formation, but very close to Percival of his concept on isostasy, does indicate the glimpse of such idea, that is root formation, indirectly. While making a comparative analysis of the views of Airy and Pratt on isostasy, Bowie has observed that the fundamental difference between Airy's and Pratt's views is that the former postulated a uniform density with varying thickness and the latter a uniform depth with varying density. The figure on the screen explains the fundamental difference between the concepts of Airy and Pratt on isostasy. Now, the isostatic adjustments on the surface of the earth. It is quite apparent that there is no complete isostatic balance over the globe. Endogenetic forces often disturb the crustal balancing. The regular earthquakes and volcanic eruptions along a particular belt do not signify any balance, but a sort of adjustment is needed continuously. Endogenetic forces and the tectonic effects are the causes of imbalance on the surface, but nature always tries to make an isostatic adjustment with itself. Exogenetic forces are trying to eliminate the differences on the surface of the earth, and in this process they are peeling off, transporting down to far flung places and depositing them. In this process, isostatic balance is maintained by underneath flowage of material by subsidence at place of deposition and upliftment at the peeling of place in their proportion to the denudation. Dear students, in the next session we will learn about the continental drift theory. Thank you one and all.